Good morning. Let us start our lecture today. So you have the two tables. Those tables are allowed in the midterms. All right. So you can keep those tables and use it. So basically, I just copy that from the book. And this is tables now 3.2.1 and table 3.2.2. All right. So basically, these are things that you can use in the exam. You can take those to the exam. But just those tables, right? So this is why I cut this page into two pieces. All right. Today we're gonna learn. We're gonna do the practice test, and let us start with the practice exam 4. The first question is to find the inverse, the Laplace transform of e to the 3t sinus of 5t. All right. So, someone has an idea how to compute this Laplace transform? Yes?
Well, we know that the Laplace transform of sine 5t would be 5 over s squared plus 25. And we know by the shifting theorem that if we multiply our function by an exponential function, then we just need to replace all our terms of s with the term s minus a, where a is the constant.
Yes, can you say at the back of the paper, please? So basically, the first thing you do is you do the Laplace transform of sinus of 5t, right? And then you check the table. So this is t3, right? So t3. The Laplace transform of sine 5t will be 5 over t squared plus 5 squared, and this is 5 over t squared plus 25. S squared, sorry. Right? So the first thing you do is you check the table and you see that in T3, in this table, right? In T3, you know that the sinus of 5t will be 5 over s squared plus 5 squared. This gives you 5 over s squared plus 25. And the next step is formula T16. Right? So this is the Shifting Theorem. So if you have a Laplace transform of e to the ct ft, then this gives you the Laplace transform shift by c, right? So the f will be the Laplace transform of ft. All right? Right, so the first thing you do is you take a Laplace transform of sinus 5t. Laplace transform of sinus 5t is 5 over s squared plus 25. All right? The next step is to use the shifting theorem. The shifting theorem says that if you take the Laplace transform of e to ct times the function ft, then this means that you shift the Laplace transform of the function f by c, which means that you have f s minus c, where f is the Laplace transform of ft. Now you apply this shifting theorem to this Laplace transform. So you're gonna get Laplace transform with 3t sinus of 5t will be f of s minus 3, right? In which f is the Laplace transform of sinus of 5t. And this is 5 over s squared plus 25. Right, so what is the final answer? Yes?
5 over s minus 3 squared.
Yes, can you say it back to paper, please? Right, so finally you have what? The Laplace transform is 3t sinus of 5t will be 5 over s minus 3 squared plus 25. For the first problem, what you see is that you have to do the Laplace transform of an exponential times the sinus function. The first thing you do is you compute the Laplace transform of sinus 5t. So you look into the table. You see that in formula T3, the Laplace transform of sinus 5t will be 5 over s squared plus 25. Right? Now what you do is that you have to multiply e to the 3t to this function. All right? So how do you do that? You use the Shipping Theorem. So if you multiply an exponential to a function, then you have to shift the Laplace transform by c. Right? So you apply this theorem for ft to be sinus of 5t and c is 3. All right? So you apply this theorem to the case where ft is sinus 5t. In this case, the e to the ct should be e to the 3t, right? So which means that you want to take the Laplace transform of this sinus 5t and you shift it by 3. The Laplace transform of the sinus 5t is 5 over s squared plus 25 because you computed it here. So now you just have to replace s by s minus 3, and this is basically the answer. Questions? It's good? Right, so there's no questions. Let us go to the next example where you have to find the inverse Laplace transform of 3s minus 5 over s squared plus 4 squared.
Is that a plus 4 or minus 4?
So it is plus 4. So how can we do it? Yes?
Would you split it up with like partial fractions?
Yes. Can you sign the back of the paper, please? So the first thing you do is that you split this into 3s minus 5 over s squared plus 4 squared will give you 3s over s squared plus 4 squared minus 5 over s squared plus 4 squared. Right? This is the easiest things that you can imagine, right? So which means that the inverse Laplace transform of 3s minus 5 over s squared plus 4 squared is going to be the inverse Laplace transform of 3s over s squared plus 4 squared minus the inverse Laplace transform of 5 over s squared plus 4 squared. So what is the next step? What is the next step? Look at the table, everything is here. So what formula should we use? Look at the table. T27, one. Good. Can you stand by the paper, please? So you want to use T27. This is one thing. T27. Inverse Laplace transform of 2b squared over s squared plus b squared is 1 over b sinus at bt, sinus of bt minus t cosinus bt. Alright? Yes? So this the first thing that we use is T27. So where can we apply T27? Which term is it? Among the two terms that I have here, which term can I use T27? Yes?
Is it the second term where we have just a constant on top or we have 5?
Yes. So why do you?
So B would be the let's see. So we need a 2 on the top. So we could multiply by 2 on the top and bottom, and then we could say that B is equal to the square root of 5.
B is the square root of 5. No, this is B squared, right? So
Oh
what?
yes, of course. Oh my goodness, yes, of course. So B, of course, would be 2.
Yeah.
B would be 2, and then we would multiply by constants perfectly, so we would get an expression on top that is equivalent to 2
Can you sign the back of
squared.
paper? Right, so you observe that here you have 5 over s squared. 5 over s squared plus 4 squared. Right? This 4 squared is 2 squared. This 4 is 2 squared, right? So this is 5 over s squared plus 2 squared. Right? 4 is now 2. 4 is now 2 squared. All right? Which means that in this case b will be 2. All right? So what should I multiply and what should I divide to the top? Right? So now so now I look at the second term, right? The second term has s squared plus 3 plus.
Multiply by 5x.
Yes, can you sign the back paper, please? Now you see that here you have b squared and here you have 4. 4 is 2 squared, right? So I want this formula to be similar to this formula, which means that b has to be 2. Right? So because here you have b squared and here you have 2, so I want the same formula of s before. So which means that here I have to have 2 times 2 squared divided by s squared plus 2 squared. And here I have 8, which means that here I have to multiply with 5 over 8. All right? Right? So explain again. Here I have 2 squared, and here I have b squared, so which means that b is 2. So here I have 2b squared, which means that here I have to multiply with 2b squared, 2 squared, which is 8. And then I have to divide it by 8, and I have to put the 5 outside. Right? Now I can apply the formula. I have 5 over 8 sinus of 2t minus t cosinus of 2t. So 1/2. Right? Now I can apply this formula, right? This formula has b to be 2, which means that here I have 1/2 sinus 2t minus t cosinus 2t. Questions? Right? I explain again. So the first thing that I observe is this term, right? This term is here. This term is similar to the formula T27, because in T27 you have 2b squared over s squared plus b squared. And in the second term you have s squared plus 4 squared, which can be written as s squared plus 2 squared squared. In this case, b will be identified with 2, which means that here I need 2 square and have to divide by 8. Now the rest of the task is easy. You just replace 2 into this formula, right? Now for the second term, what is the formula that we use?
Would you be able to modify T25?
Yes. So you think that is T25? Yes. Can you sign the back of paper, please? All right. So the next term, which is this term, can be computed using T25, right? So T25. What is T25? So T25 said that the Laplace transform of t sinus vt is 2bs over s squared plus b squared squared. Right? I use T25 because on the bottom I have s. On the top I have s, and on the bottom I have s squared plus 4. Right? Right. So now I have to compute the inverse Laplace transform. So T25 means that the inverse Laplace transform of 2bs over s squared plus b squared squared is t sinus bt. All right. So now I have to compute the inverse Laplace transform of 3s over s squared plus 4 squared. Right. So how can I do it? Yes.
Multiply by 3/4.
Yes. Can you send back the paper, please? So now, when you look at this formula, you can see immediately that b should be 2, right? So this will be inverse Laplace transform of s squared plus 2 square, and then here too you have 2s, and then here you have 2 divided by 4, right? Right. So now you look at T25, you know that the inverse Laplace transform of 2bs over s squared plus b squared is tbt, right? The formula that we have is 3s over s squared plus 4 squared squared. So I write s squared plus 4 as s squared plus 2 squared. And because here I have 2bs, I have to have 2 times 2s. So I divide by 4. So here I multiply 3/4, right? And the result will be 3 over 4. 3 over 4 of t times sinus 2t. All right? Questions? Right. So now I have everything, which means that here I can replace the formula that I have here to be 3 over 4 sinus 2t, t sinus 2t minus 5 over 8 sinus 2t minus t cosinus 2t. Right? Questions? So the key here is that you need to know how to use this table. Once you know how to use this table, then it is simple, right? So you need just to identify among the terms that you have which one correspond to the formula in this, right? Right. Right, so let us go to the first question. So the third questions will be solving differential equation using the Laplace transform. So you need to solve y second plus y is equal to sinus t with the initial condition y is 0. Is y prime at 0, and this is 0. So basically you see the structure of the midterm, right? So in the midterm you will have 3 questions. The first one will be Laplace. The second one will be inverse Laplace. And the third one will be solve an ODEs. So this is 5 points, this is 5 points, and this is 10 points. Then there will be extra questions for bonus points, right? So I explained, so in the exam, the total points is 20. first question is Laplace transform, which is 5. The next one is 5. The next one is inverse Laplace transform. And the last one is to solve a differential equation. But in the differential equation, you have to use the Laplace transform, right? So this equation, you can solve it using the undetermined coefficient method. But here you have to use Laplace transform, right? By Laplace. So this equation can be solved by the undetermined coefficient method. Right, so this one can be solved by an undetermined coefficient method, which means that first you have to find the particular solution, and then you solve the homogeneous equation and you take a sum, right? But here we solve by the inverse Laplace transform, right? So by Laplace transform. So the first thing you do is you take the Laplace transform on both sides. You have Laplace transform y prime plus y is equal to Laplace transform sinus t. So what is the Laplace transform of sinus t? Yes?
1 over s squared plus 1.
Yes, can you say at the back of the paper, please? So you know that the Laplace transform of sinus t is 1 over s squared plus 1. All right? Now, then you have y second plus y will be Laplace transform of y second plus Laplace transform of y. So, what is the Laplace transform of y second? Yes?
Is it s squared times the Laplace transform of y, and then because the other two are 0.
Yes. Yes, can you send back the paper, please? So this is s squared Laplace transform of y minus s y0 minus y prime at 0, right? And because the other two are 0, so you can reduce it to s squared Laplace transform of y, right? Right? So I explain again. When you do the Laplace transform on both sides of the equation, you know exactly that the Laplace transform of sinus t is 1 over s squared plus 1. All right? Now we have to do the Laplace transform of the right-hand side. The Laplace transform of the right-hand side will be Laplace transform of y second plus Laplace transform of y. So now you have to do the Laplace transform of y second. The Laplace transform of y second will be s squared Laplace transform of y minus s y0 minus y prime at 0. This is 0 and this is 0. So finally you get s squared Laplace transform of y. So what is the next step? Yes?
Factor out the Laplace transform of y.
Yes, can you send back the paper, please? So you put everything into the equation. So you have s squared Laplace transform of y plus Laplace transform of y is equal to 1 over n squared plus 1. Right? So you put Laplace transform of y to be the common factor. So you have s squared plus 1. Laplace transform of y is 1 over s squared plus 1. And this gives you Laplace transform of y is 1 over s squared plus 1 squared. So I explain again. after you do this Laplace transform of y second, you get s squared Laplace transform of y. You plug everything into the equation. You have s squared Laplace transform of y plus Laplace transform of y is equal to s squared plus 1, right? So you put Laplace transform of y to be the common factor. You have s squared plus 1 Laplace transform of y is equal to s squared plus 1, which means that the Laplace transform of y will be 1 over s squared plus 1 squared, right? Now you have to do inverse Laplace transform of this guy. So what formula should I use? Yes?
Number 27.
Yes, can you sign the back of the paper, please? So we use the 27 again, right? So in the 27, the Laplace transform of the inverse Laplace transform of 2b squared over s squared plus b squared is 1 over b sinus bt minus t cosinus bt. All right. So what is the value of b in this case? Yes.
1.
Yes. Can you sign the back of the paper, please? So here you see that you have s squared plus 1, and here you have s squared plus b squared, which means that b has to be 1. So then I can write this like first Laplace transform, so which means that b is 1 of 2 times 1 square over s squared plus 1 square, and then you have to divide by 1/2, right? This gives you 1/2 sinus t minus t cosinus t. All right? So the exam will be as simple as this. You can finish this in 20 minutes, right? Questions? It's clear? Right, so basically the key is that you have to bring this table to the exam, right? If you don't bring it, you are not allowed to open the book. So this is the key, right? So you are not allowed to open the book, you are not allowed to open your cell phone, yes?
Do you have any more of those margers?
I think it's somewhere there. Right, so this is your key. So you are not allowed to open the book and the cell phone, and the laptop. So this is the only thing that you can bring into it. So don't forget to bring it. And if without that one, you will not be able to remember all of those formulas.
You may have more of those.
All right, so let us go to the next practice exam. So practice exam 5. So the first question is to find the Laplace transform of e to the power minus 40 t to the power 6 plus 60 squared plus 5t plus 4. So this is the Laplace transform that you need to find. You need to find the Laplace transform of exponential minus 40 times t to 6 plus 6t squared plus 5t plus 4. Right? So what formula should we use? Yes?
T16.
T16. Right, can you sign back the paper, please? So T16 is always the shifting formula, right? So you have what? You have the Laplace transform of e to the ct, ft will be f of s minus c. So which means that g is the Laplace transform of f. Right? So which means that whenever you see an exponential, you can use the shifting theorem, right? And here you see that there is an exponential here. that means that you can use the shifting theorem. So what is the function f in this case? Yes?
The whole polynomial.
Yes. Can you send back the paper, please? So the whole polynomial will be the function f plus 6t squared plus 5t plus 4. All right. So the Laplace transform of e to the 4t of t to the 6 plus 6t squared plus 5t plus 4 will be f of s plus 4, right? Because this is s minus 4, and this is f of s plus 4, and f will be the Laplace transform of t to the 6 plus 6t squared plus 5t plus 4, right? I explain again. Whenever you see an exponential, you use the shifting theorem to ignore that. So now here you see an exponential. You have e to the minus 40 times something, which means that when you use the shifting theorem, you have to shift the Laplace transform of the guy inside by 4. So now we have to compute the Laplace transform of t to the 6 plus 6t squared plus 5t plus 4. So what is the formula that we use here? Yes?
Would you just do like the individual Laplace transformations of like the t to the 6 with the n factorial over s to the n plus 1?
Yes. Can you sign the back of the paper, please? So the formula that you use is T9. The T9 said that if you have a Laplace transform of t to the n, you're gonna get n factorial as n plus 1. Right? So the T9 says that you can take the Laplace transform of t to the n will be n factorial over s n plus 1, and I can apply this here, right? So now the Laplace transform of t to the 6 plus 6t squared plus 5t plus 4 will be Laplace transform of t to the 6 plus 6 Laplace transform of t squared plus 5 Laplace transform of t plus 4 Laplace transform of 1, right? So that so the formula that we use will be the Laplace transform of t to n is n factorial over s to power n plus 1. So now I have to compute this Laplace transform. I break it into 4 terms. So what is the Laplace transform of the first guy?
6 factorial over s to the 7.
Yes, can you send back the paper, please? So this is 6 factorial over s to the power 7. What is the second guy? Yes?
12 over s cubed.
What?
12 over s cubed.
Can you send back the paper, please? So this is 12 over s cubed. And the last one? The third one? Yes?
5 over s squared.
Yes, can you send back the paper, please? This is 5 over s squared. And the last one? Yes?
4 over s.
Yes, can you send back the paper, please? This is 4 over s. You remember what is 0 factorial, right? What is 0 factorial? 1, yes. So here 0 factorial is 1. This is why you can still apply this formula. And basically this is the, so the 6 factorial will be 70 and 72, I think. 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. So this is 30. This is 120. This is 36. This is 72. This is 7. Right. So what is the the final answer of this. So now. Right, so what is the final answer of this Laplace transform? Yes?
You just plug in s plus 4 into all the places where we have s.
Yes, can you say it back this? So now you can, because of this formula, right? You can replace s plus 4 to anywhere you have s. So this gives you 720 over s plus 4 to the 7 plus 12 over s plus 4 to the 3, 5 over s plus 4 to the 2 plus 4 over s plus 4. All right? It's clear? Questions? Right, so basically the key here is that whenever you have an exponential, you remember to use the shifting theorem. Shifting theorem, you are supposed to remember the shifting theorem, but it is put in the table, so you don't have to remember it. You just remember that it is T16. So, right, so whenever you have an exponential, you just shift the Laplace transform of the function without exponential by the c. Right, and then you do the Laplace transform of the guy without the exponential, right? So here you go from here to here without the exponential, and you do it normally, and at the end you replace the shift to the variable x. Questions? All right, so let's go to the next example. The next. So the first question is always 5 points. So the next exercise, you have to compute inverse Laplace transform of 5 over s squared plus 9 squared. What formula should we use? Yes. Teacher? No? Any better guess? Yes? Yes, T27. So this T27 is very important, right? So this is always T27. So T27, what you have is the inverse Laplace transform of 2b squared over s squared plus b squared squared is 1 over b sinus bt minus t cosinus bt. All right, so this is T27. What is the b here? Yes? Yes, can you send back the paper, please? So here you say you have b squared, here you have b 9, so b is definitely 3, right? So then you're gonna have inverse Laplace transform of 5 over s squared plus 9 squared will be inverse Laplace transform of s squared plus 3 squared square to 3 squared, and then you have to divide by 18, and this gives you 5 over 18, 1 over 3 sinus 3t minus t cosinus 3t. And that's it, right? All right, so for this problem, you check the table, and this is similar to T27. In T27, you have 2b squared over s squared plus b squared squared, which means that this b squared has to be 9 and b has to be 3. So you use this formula. So here you have x squared plus 3 squared, and here you have to multiply with 3 squared times 2, which means that you have to divide by 18, and this gives you this formula, right? Questions? It's clear? So this is another 5 points. Yes. So the next exercise, yes?
And so on that one, why would you use 25?
25.
Why do you choose 227 over 225?
Okay, because if you want to use 325, you have to have an S here. Right, so 325 has an S on the top, and 227 doesn't have an S, right?
Okay.
So if I ask you to do this guy, then it has to be 325. Right, so questions number 3. You need to solve y second plus 4y is equal to sinus of 2t plus cosinus of 2t, and y0, y prime is 0 is 0, right? So the first step is what? Yes?
Take the Laplace of both sides.
Yes, can you sign the back of the paper, please? You're gonna Laplace transform both sides, right? So the first step is always taking the Laplace transform of both sides. So what is the Laplace transform of 2t? 2 can you sign the back of the paper, please? So this is t over s. This is 2 over s squared plus 4. And then, what is the Laplace transform of cosinus 2t? Yes?
S over S squared plus 4.
Yes, can you sign the back of the paper, please? So you're going to have s over s squared plus 4. Right? So I explain again. The first step is to take the Laplace transform of both sides of the equation. You take the Laplace transform y second plus 4y, and then you take the Laplace transform sinus 2t plus cosinus 2t. The Laplace transform of sinus 2t will be 2 over s squared plus 4, and the Laplace transform of cosinus 2t will be s over s squared plus 4, right? Now, let us look into the left-hand side. You're going to have this guy. So this is Laplace transform y second plus 4 times Laplace transform of y. All right? So what is the Laplace transform of y second? Questions? Yes?
S squared f of s minus s f of 0 minus f prime 0.
Let's can say the back of the paper, please. So this is going to be s squared Laplace transform of y minus s times y0 minus y prime of 0. Right? So what do we get? Yes?
Just the S squared Laplace transform y.
Yes, can you sign at the back of the paper, please? So this is just s squared Laplace transform of y, because the other term is 0, right? You use the initial condition, and they're both 0. What is the next step? Yes?
Factor out of the Laplace transform y.
Yes, can you sign at the back of the paper, please? Now I put everything into the equation. I have s squared Laplace transform y plus 4 times Laplace transform y is equal to 2 over n squared plus 4 plus s over n squared plus 4. All right. Now I have s squared plus 4. Laplace transform y is equal to s plus 2 over s squared plus 4. And so the Laplace transform y will be s plus 2 over n squared plus 4 squared. Right? So y will be inverse Laplace transform of s plus 2 over s squared plus 4 squared. Right? I explain again. So we know that the Laplace transform of y second is s squared Laplace transform of y because these two terms are 0. So I plug everything back into the equation. I have s squared Laplace transform of y plus 4 times Laplace transform of y is 2 over s squared plus 4 plus s over s squared plus 4. So I put Laplace transform of y as a common factor. I have s squared plus 4 Laplace transform of y. The right hand side I have s plus 2 over s squared plus 4. I divide both sides by s squared plus 4. I get Laplace transform of y is s plus 2 over s squared plus 4. Then y will be the inverse Laplace transform of this guy. So what is the next step? Yes?
Why don't you split it back apart so you can do the individual Laplace transform?
Yes, can you stand back the paper, please? So I'm going to split s into 2. Right? So y will be the inverse Laplace transform of s over s squared plus 4 square plus 2 inverse Laplace transform of 1 over s squared plus 4 square. All right. So for the first Laplace transform, inverse Laplace transform, what is the formula that we should use?
The T25.
Yes, can you stand back the paper, please? Now you use T25 because you have an S on the top. Right, so now you use T25, which is the point. The T25 says that Laplace transform of sin s pt 2bs over s squared plus b squared. Right, in T25 isn't written in the Laplace transform way, but it means that the inverse Laplace transform of this guy is also the other guy, right? So you can use both formula. Right? So normally in those formula you have only one Laplace transform because either is it inverse or is it Laplace transform. So if you in T25 you have that Laplace transform of T sin s pt is this guy, which means that you can use the formula, the inverse formulas. They are equivalent. So now what is the b in this case? Yes? No. 2. Yes, can you slide the backup paper, please? So, so the b here should be 2, right? Because 2 squared is 4. So now I have the inverse Laplace transform of 2 times 2s over s squared plus 2 square, and then I have 1/4. And this gives me 1/4 of t sin s of 2t. All right? I explain again. So in T25, you have an S on the top, which is suitable for the first inverse Laplace transform, right? In T25, b square, you have b square, and here you have 4, which means that b has to be 2. You replace 2 here. So you have 2 times 2 times s over s squared plus 2 squared. So you have to divide by 1/4 because you multiply by 2 times 2. You apply the formula, you get 1/4 of sin s 2t, right? So this gives you 1/4 of t sin s 2t. For the second one, what is the formula that we use? Yes?
T27?
Yes, can you slide back the paper, please? So now you're gonna have to compute the second one, which is T27, right? So T27, you have what? The inverse Laplace transform of 2b squared over s squared plus b squared is 1 over b sin s bt minus t cosine s bt. So what is the b in this case? Yes? 2, yes. Can you stand back a bit, please? So in this case, again, b is 2 because you have 4 and you have this space here. So now you're gonna compute this, and this gives you 2 inverse Laplace transform of 1 over s squared plus 4 square, and this is inverse Laplace transform of 2 times 2 square over s squared plus 4 square, and you have to divide by 8. So this is 1/4 of 1/2 sinus 2t minus t cosinus 2t. Now you put everything back into the formula, and you get what? You get 1/4 t sinus 2t plus 1/4 1/2 sinus 2t minus t cosinus 2t. All right? Questions? So basically the exam will be like that, right? So you try to see which formula you can use in the 2 tables, and you plug it back into the general formula, and you get the answer. Any questions? Yes?
When we use T25, why didn't we use T4?
T4. No, T4, so you have to be careful for all of those formula, because in T4, you has s squared plus b squared, another square outside. Right? So here you have the square. T27 and T25, you have the square. And in T4, you don't have the square. Right? So I mean, so you have to choose carefully those formulas, right? And you see that here you have a square, and in our formula we have the square. So this is why you have to choose T25 and T27. T4 is u in the beginning, right? So remember that in the beginning we have to compute the Laplace transform of sinus 2t, and then you compute the Laplace transform of sinus cosinus 2t, right? This is the beginning, and in the beginning, this is T3, and this is T4. So we use T4 in the very beginning to compute the Laplace transform of the right hand side. But when you do that, you have s squared plus 4 and no square, right? And when you have the square here, you have to use 225 and 327. Questions? All right, so we finished with the practice tests. Questions? Any further questions on this? So basically in the test, you're gonna have 3 questions, right? The first 2 will be 5, and the last one will be 10. So those questions will be easy because you have a table, so you know how to use the table and the basic computation, and you will be fine. Right. So if there's no questions, so let us go to our lecture again. So example, you have to compute the inverse Laplace transform of s minus 3, s minus 8 over s minus 5, s squared plus 2s plus 5. So this is much more difficult than the exam, right? Any ideas how do you think we should start with? you have to compute the inverse Laplace transform of s minus 5 as s minus a over n minus 5 plus s squared plus 2s plus 5. Yes?
Should we use partial fractions?
Yes,
to
can
look
you
it up
say
first?
please? So now you're going to use partial fraction, right? So you have 2s plus 5. What is the form of the splitting in the partial fraction? Yes?
Would it be a over s minus 5 plus bs plus c over s squared plus 2s plus 5?
Yes. Can you say it at the back of the paper, please? So you have a over s minus 5 plus gs plus c over s squared plus 2s plus 5. Right? Questions? Why do I have bs plus c?
Is it
Yes?
because you have like s squared plus 2s?
Yes. Can you stand back the paper, please? Because here, this s squared plus 2s plus 5 cannot be factorized anymore, which means that I have to keep it in the bottom, right? Because I keep it in the bottom, on the top, I have, because this is of order 2, right? So on the top, I have to keep order 1, right? So remark. So other example. So suppose that you have s minus a over s minus 5 as 3 plus 5s plus no, this is not a good example. Well, so suppose that you have s4 plus 5, right? So for this case, how can I split it? Yes?
Would it be a over s minus 5 plus bs cubed
Right.
plus c s squared plus
Can you say it back to
ds
paper, please?
plus e, and then that over s.
Right, so you split it into all of the fraction that contains those things separately, right? So because in the bottom you have something of order 4, so which means that here you have to have something of order 3. Right? So basically the degree of the top is the degree of the bottom minus 1. So this is degree 1. Which means that here you have to have degree 0. This is degree 4. This means that here you have to have degree 3. Right? Okay, questions? Alright, so let us go to this splitting. Now, this gives me a s squared plus 2s plus 5 plus s minus 5 bs plus c over s squared plus 2s plus 5 s minus 5. Alright, so which means that I have s minus 8 is equal to a s squared plus 2s plus 5 plus s minus 5 bs plus c. Right? Explain again. First, I'm going to split s minus a over s minus 5 s squared plus 2s plus 5 as the sum of these two guys. Why do I split it into the sum of these two guys? Because here I have two polynomial, which means that I have two fractions. The first one, s minus 5 is of order 1, so here I put something of order 0. And this guy is of order 2, which means that here I have to put something of order 1. Alright? So now, this sum is equal to a s squared plus 2s plus 5 plus s minus 5 bs plus c. Which means that s minus 5 is a s squared plus 2s plus 5 plus s minus 5 bs plus c. How can I compute a? I want to compute this a. How can I compute it? Yes?
So s equal to 5.
Yes. Can you sign back the paper, please? So now you set n to be 5. Right? You set n to be 5 so that you can kill this term, right? So you have 5 minus 8 is equal to 8. 5 squared plus 2, 5, plus 5, plus 5 minus 5, B5 plus C, right? Now I set S to be 5, which means that here I can kill the second term. Right, so I have minus 3 is equal to A. 25 plus 10 plus 5, which means that minus A is equal to A times 14. So A will be minus 3 over 40. Right? I explain again. So because here S minus A is A squared plus 2S plus 5 times S minus 5 plus BS plus C, which means that here I have 5 minus A is A 5 squared plus 2 times 5 plus 5 times this guy. This guy is 0 because I set S to be 5 so that I kill it. So the next one will be minus 3 is A 25 plus 10 plus 5, so A is minus 3 over 4t. Now I plug everything back into the equation. So I have S minus A is minus 3 over 40. Alright? And then I have S squared plus 2S plus 5 plus S minus 5 BS plus C. Right? What is the next step? Yes?
You said S equals 0, it's all for C.
So you set S to be 0. It's not enough to set S to be 0 so for C because when S is yes, that's good. You can sign at the back of this. Right, so you set S to be 0. So you have 0 minus A is equal to minus 3 over 40, 0 plus 2 times 0 plus 5 plus 0 minus 5 times B times 0 plus C. Right? So when you set S to be 0, you can Q B. Alright? So then I have minus 8 is equal to minus 3 over 40 times 5 plus minus 5 times C. Alright? So this is minus 8 is equal to minus 3 over 8 minus 5C, which means that 5C is 8 and this is 60 minus 3 over 8 and this is 61 over 8. So C will be 61 over 40. Right? So I explain again. So here I have S minus 8 is minus 30 over 3 over 40, S squared plus 2S plus 5, X minus 5, BS plus C. Right? So I set S as S to be 0 and replace 0. Here I have 0 minus A is equal to minus 3 over 40. I have 0 plus 2 times 0 plus 5. I have 0 minus 5 plus B times 0 plus C. So this B is Q. So here I have minus A is equal to minus 3 over 40 times 5. Here I have minus 5 times C. So minus 3 over 40 times 5 is minus 3 over 8 minus 5C. So which means that I can put 5C here and 8 here. So I have 5C is 8 minus 3 over 8. And this is 64 minus 3 over 8. Right? And this is 61 over 8. So C is, you divide by 5. So you have 61 over 40. Right? So I have A, I have B. So how can I find B? Yes?
Set S equal to 1.
Set S is, yes, you can set S to be anything, but there's one faster way to see it. Yes?
It would be fastest to set S equal to 8. So you go to 0 term.
So you set S to be 8. Yeah, but there's still a faster way. Yes?
Do you compare coefficients based on the degree of S
Yes.
on both sides?
Yes.
And you see what B would have to be in order to satisfy the
Right.
equation.
So can you stand back the paper, please? So you see that here you don't have S squared, and here you have S squared. So what is the coefficient of s squared on the right hand side? Yes, on the right hand, on the left hand side is 0. But what is the coefficient of the s squared on the right hand side? Yes.
Negative 3 over 40.
There's something missing, right? So
Yeah.
yes.
A plus b, and we know a, so that way it'll be negative 3 over 40 plus
Yes.
b.
Can you stand back to paper, please? So if you look into this formula, right? So on the left hand side, you don't have s squared. On the right hand side, you have one s squared, and here you have another s squared, right? The coefficient of s squared on the left hand side of star is 0, right? So on the left hand side of this equation, you don't have s squared. On the right hand side, you have minus 3 over 40 plus b, right? Because here you have minus 3 over 40 s squared, and here you have b s squared. And on the right hand side, the coefficient of s squared on the right hand side of s of star is minus 40 over plus b. So which means that b minus 40, 3 over 40 is 0, which means that b is 3 over 40. Right? It's good. I explain again. If you look into this equation, on the left hand side you don't have s squared. On the right hand side you have minus 40 s squared. Minus 3 over 40 s squared. This is one guy. And another guy is s times bs, which is bs squared. So the coefficient of s squared on the right hand side is b minus 3 over 40, right? So the coefficient of s squared on both sides has to be the same, which means that b minus 3 over 40 is 0, which means that b is 3 over 40. Questions? It's good? Right, so we go here. We plug everything back to this form, right? So you have minus 3 over 40, 1 over s minus 5, plus 3 over 40b, plus 61 over 40 over s squared plus 2s plus 5. All right? Now you have to compute the inverse Laplace transform. S minus 8 over s minus 5, s squared plus 4s, 2s plus 5 is going to be minus 3 over 40 inverse Laplace transform of 1 over s minus 5 plus 3 over 40 inverse Laplace transform of yes s over s squared plus 2s plus 5 plus 60 over 40 the inverse Laplace transform of 1 over s squared plus 2s plus 5. Right? So after all of those computations, you know that a is minus 3 over 40, b is 3 over 40, and c is 61 over 40. Plug everything into this form, right? So now the inverse Laplace transform of s minus a over s minus 5, s squared plus 2s plus 5 should be minus 3 over 40, the inverse Laplace transform 1 over s minus 5, plus this guy, which is 3 over 40, the inverse Laplace transform of s over s squared plus 2s plus 5. The last guy is 61 over 40, the inverse Laplace transform 1 over s squared plus 2s plus 5. All right. So what is the inverse Laplace transform of 1 over s minus 5? Yes?
E to the 5b.
Yes, can you sign back to paper, please? So the first guy is minus 3 over 40. Inverse Laplace transform of 1 over s minus over 40 e to the 5t. Right? So now we have to compute in 3 over 40 of the inverse Laplace transform of s squared over 2s plus 5. What formula should we use? Yes.
Should we try to complete the square of the bottom term and then use the formula for cosine dt?
Yes, can you sign back the paper, please? All right, so here you have 3 over 40. Right, so I think I better not to split it this way because, yeah, right. So let us observe this. S squared plus 2s plus 5 will be s squared plus 2s plus 1 plus 4, right? And this is s plus 1 square plus 2 square, right? Yeah, I think I better not split here because, so I'm gonna keep the inverse Laplace transform of this guy, the whole thing. 3 over 40 s plus 61 over 40 over s squared plus 2s plus 5. All right. First, I complete the square with the bottom. So the bottom is s squared plus 2s plus 5. I split it into s squared plus 2s plus 1, right? Plus 4. And so this gives me s plus 1 square plus 2 square, right? So now I'm gonna see this guy. So this guy will give me the inverse Laplace transform of 3 over 40 s plus 1, right? Plus 61 minus 3 is 61 minus 3 is 57 over 40 over s plus 1 square plus 2 square, right? So so here I have two terms, this term and the second guy. The second guy is the inverse Laplace transform of 3s over 40 plus 61 over 40 s squared plus 2s plus 5. So s squared plus 2s plus 5, I can complete a square, and I have s squared plus 2s plus 1 plus 4. This gives me s plus 1 square plus 2 square. So I put it here, right? But here I have s plus 1. So I split the top. So I split this into 3 over 40 s plus 1 plus 58 over 40 because I put 3 into the other term, right? Questions? It's good. Now, what formula should I use? Yes?
Can you use T6?
Yeah, so this is T6. Yes. So now we're going to use T6, right? So the first guy is 3 over 40 inverse Laplace transform of s plus 1 over s plus 1 square plus 2 square plus 50 over 40 of the inverse Laplace transform of 1 over s1 square plus 2 square, right? So the first one, I can use T6. What is T6? So T6 says that the Laplace transform of e to the at cosinus of bt will be s minus a over s minus a square plus b square, right? So the first one can be computed using T6. What is a and what is b in this case? Yes?
A will be minus 1 and B will be 2.
Yes, can you sign back the paper, please? So this guy will be like this, with A to be minus 1 and B is 2. So for this, I get 3 over 40 e to the minus t cosinus of 2t. Right? for the second formula, what is the, which formula in the table should I use? Yes?
T formula.
T what? T5, yes.
T5.
Can you sign back the paper, please? So for the second one, you're going to use T5. So for T5, you have Laplace transform p to the at sin s of bt is b over s minus a squared plus b squared. So what is a and what is b in this case? Yes?
Won't it just be the same, that a is -1 and
Yes.
b is 2?
Can you sign back on paper, please? So for the second formula, I'm going to use a to be -1 again, and b is 2. All right, so here I'm going to have, but here I need the 2 right here. So I have 2 here, and here I have 29. So this basically gives me 29 over 40 times e to the minus t sin s 2t. Right? And then you take the sum of this guy and this guy. Then you have the inverse Laplace transform that you want. Right? So basically this is minus 3 over 40 e to the 5t plus 3 over 40 e to the power minus t cosine of t 2t, and the other one is 29 over 40 e to power minus t sin s of 2t. Right? I explain again. To compute the inverse Laplace transform of this guy, what you do is you split it into one fraction with s minus 5 and one fraction with s squared plus 2s plus 5. Why? Because here you have the product of these two polynomials, and s squared plus 2s plus 5 cannot be factorized anymore, right? So here you have s minus 5, which means that here you have to put something of order 0. Yeah, 2 minutes, right? So you have s squared plus 2s plus 5, which means that here you still have something of order 1, right? So after you identify the coefficient, right? So you found a is minus 3 over 40, b is 3 over 40, and c is 61 over 40. You have this form and this form. The first guy, you have to compute the inverse Laplace transform 1 over s minus 5. This is easy. You get e to 5t. No problem. The second one is a little bit trickier because you have 3 over 40 s plus 61 over 40 s squared plus 2s plus 5. So what you do is you complete a square. You have s squared plus 2s plus 5 can be written like s squared plus 2s plus 1 plus 4, and this gives you s plus 1 squared plus, so the 4 is 2 squared, right? So you write like s plus 1 squared plus 2 squared. Because in the bottom you have s plus 1 squared, you have to write the top in terms of s plus 1, right? So here you have 3 over 40 s plus 1, which means that here you have to subtract 3 from 61, and then you have 58, right? So then you can compute the inverse Laplace transform of the first guy, which is this one, and the second guy, which is 2 over s plus 1 plus 2 squared. Now you check the table. You see two formula. The first one is e to the at equals sinus bt, s minus 2 over s minus 2 squared plus b squared. So you identify b with minus 1 and a with minus 1 and b with 2. Right? Questions? It's good? All right, so